Good morning, children. This is Mrs. Sati Joseph, your physics teacher. Welcome back to the online teaching for the session 2020-21. We will continue with the same chapter, that is chapter 11, Work and Energy. In the previous video, I had explained to solve some numericals. I hope all of you understood. Today, we will see what is potential energy, what is the expression for calculating potential energy, and also we will solve some numericals related to potential energy. Suppose a brick is lying on the ground. It has no energy, so it cannot do any work. Let us lift this brick to the roof of a house. Now some work has been done in lifting this brick against the force of gravity. This work gets stored up in the brick in the form of potential energy. Thus, the energy of a brick lying on the roof of a house is due to its higher position with respect to the ground. And if this brick falls from the rooftop, it can do some work in breaking the window panes or somebody's head. The energy of brick lying on the rooftop is known as gravitational potential energy because it has been acquired by doing work against gravity. So what is potential energy? Potential energy of an object is the energy possessed by it by virtue of its position or configuration. I'll repeat. Potential energy of an object is the energy possessed by the object by virtue of its position or configuration, means different shapes. For example, a brick lying on the roof of a house has potential energy due to its higher position. A stretched caterpillar is also possess potential energy. A bird flying in the sky has potential energy as well as kinetic energy. A bird sitting at a height has only potential energy. Let us see one activity, that is activity number 8, which is given in your NCERT textbook. Take a rubber band, hold it at one end and pull from the other. The band stretches. Release the band at one of the ends. What will happen? The band will tend to regain its original length. It is because the band had acquired energy in its stretched position. So when you release one end, due to this acquired energy, it will come back to the original position. We see another activity, that is activity number 11. Lift an object to a certain height. The object can now do work. It begins to fall when released. This implies that it has acquired some energy. If raised to a greater height, it can do more work and hence possess more energy. So the amount of energy possessed by the object depends upon the height. More height means more energy. Less height means less energy it possesses. Some more examples are given. Just go through that one. In all these situations, the energy gets stored due to the work done on the object. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or speed of the object. For example, you transfer energy when you stretch a rubber band. The energy transferred to the band is its potential energy due to its shape, change in the shape. Some energy will be stored in that one as potential energy. When you wind the key of a toy car, some energy will be stored in the toy car, and as you release the key, the toy car will move at a distance. So when you wind the key, and the stored energy will be released. Due to that, the toy car can move at a distance. The energy stored in the car will be used to make the car move. Water stored in a reservoir also possesses potential energy. When you release this water, it can rotate the turbines of a generator. So the potential energy possessed by the object is the energy present in it by virtue of its position or configuration. What is potential energy? The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Our next topic is potential energy of an object at a height. The potential energy of a body is due to its higher position above the earth, and it is equal to the work done on the body against gravity in moving the body to that position. So, to find out the potential energy of a body lying at a certain height, all that we have to do is to find out the work done in taking the body to that height. Consider an object of mass m. Consider an object of mass m. Let it be raised through a height h from the ground. A force is required to do this. The minimum force required to raise the object is equal to the weight of the object. The weight of the object is equal to mass into acceleration due to gravity. That is m into g. The object gains energy equal to the work done on it. When you do some work an equal amount of energy will be used up. So the work done will be equal to the energy used up. Let the work done on the object against gravity be W. So work done is equal to force into displacement, and force is equal to mass into acceleration due to gravity, and h is the displacement. So that is equal to m into g into h. Work done is equal to m into g into h. Since work done on the object is equal to mgh and energy equal to mgh unit is gained by the object, and this is the potential energy of the object. So potential energy is equal to m into g into h. So what is the formula for calculating potential energy? That is equal to m into g into h, where m is the mass of the object, g is the acceleration due to gravity, and h is the height. You have to by heart this formula for solving the numericals. Let us solve one numerical question related to potential energy. Example number 5 in your textbook. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground. Given g is equal to 9.8 meter per second square. So in this question, mass of the object is given as 10 kilogram and the displacement or height h is equal to 6 meter, and the acceleration due to gravity g is equal to 9.8 meter per second square. Now what is the formula for calculating potential energy? That is m into g into h. So by substituting these values in the formula, we will get 10 kg into 9.8 meter per second square into 6 meter. When you multiply this one, you will get the answer as 588 joules. So what is the potential energy possessed by this object? That is equal to 588 joules. Let us solve another question. Example number 6. An object of mass 12 kg is at a certain height above the ground. If the potential energy of the object is 480 joules, find the height at which the object is with respect to the ground. Given g is equal to 10 meter per second square. So in this question, mass of the object is given as 12 kilogram and potential energy is given as 480 joules. You have to find the height at which the object is with respect to the ground. H you have to calculate. So what is the formula for potential energy? Potential energy is equal to m into g into h. Substitute the values, that is 480 joules is equal to 12 kilogram into 10 meter per second square into h. H you have to calculate here. Okay. Now by solving, you will get h is equal to 480 joules upon 120 kilogram meter per second square. Simplify that. That is 12 fours are 48. 0, 0 will cut. 0 and 0 you can cancel. 12 fours are 48. So your answer is 4 meter. So the position of the object is 4 meters above the ground. I hope all of you understood. This is the end of today's video. Thank you. Bye bye and take care.